So hello guys and welcome to my channels. Today again I am back with another important numericals. And this numerical is also frequently asked in the final exam of transmission line design subject. So here in this numericals we have to select the most economical and technical voltage levels and number of circuit for transmission line to transmit 140 megawatt of power over a distance of 100 kilometers. And here the distance is given as 100 kilometers and the power of 140 megawatt. Assuming single circuit line with source impedance of 400 ohm is given here, and the length and the multiplying factors. The table for length and multiplying factors is given here, sir. And here multiplying factors is represented as MF. So let's start the solutions. So the very first step we are going to do is we have to determine the most economical voltage. And here we have the formula to determine the most economical voltage, that is V in kilovolt is 5.5 and length root under length in kilometer upon 1.6 plus power in megawatt into 1000 upon 150 NC cos pi. And for single circuit the value of NC will be 1. Similarly for double circuit the value of NC will be 2. So first here I have calculated the value for single circuit, that is NC is equals to 1. So V is equals to 5.5. Length in kilometer is given as 100 upon 1.6 plus power in megawatt is 140 into 1000 upon 150 into NC is 1. Again cos pi we have assumed the value as 1. So you'll get here 173.362 kilovolt. And for double circuit NC is equals to 2. We have calculated the value for V as means most economical voltage as 126.519 kilovolt. And here this is the empirical formula to calculate the most economical voltage. And here we can see for single circuit we have obtained 173.362 kilovolt. Similarly for double circuit we have obtained as 126.519 kilovolt. So we can conclude here, since 126.59 kilovolt is nearer to 132 kilovolt standard voltage level, so 132 kilovolt is the most economical voltage. And for transmission line capability curve data using 2-point formula here we can use, we know 2-point formula is given as y minus y1 equal to y2 minus y1 upon x2 minus x1 and x minus x1. And here since the length is given as here 100 kilometers, so here we'll use a 2-point formula to calculate here. 80 here we have 80 and 160 means 100 kilometer lies between 80 and 160. Similarly multiplying their respective multiplying factor is given as 2.75 and 2.25. So here we have y minus y1. So first for y1 we have 2.75 in the table as shown in the table, and y2 is 2.25 and again y1 is 2.75 and x2 minus x1 is here this is x1, this is x2, similarly this is y1 and this is y2, and these values are substituted in the 2-point formulas. So in this 2-point formula we have used y minus y1 equal to y2 minus y1 upon x2 minus x1 and x minus x1. So you'll get y as 2.75 minus 0.5x upon 80 plus 0.5, and the line distance is given as 100 kilometers. So here we will use the value for x is equals to 100 kilometers. So y will be 2.625 means y, this is the multiplying factor. So the new multiplying factor for 100 kilometer is 2.623 for 100 kilometers. Now we have to calculate the source impedance loading. So for source impedance loading we have the formula as V square upon ZC upon NC, and for single circuit lines we have NC is equals to 1, so 132 square upon, and impedance ZC is given as 400 ohms. Here we have given the impedance as 400 ohms. And here we have selected the economic voltage as 132 kilovolt. So B in place of B have 132 and ZC as 400, and for single circuit NC is equals to 1. So on calculating we will get here 43.56 megawatt. Similarly for double circuit lines 132 square upon 400, and for NC for double circuit NC will be 2, so you'll get here 87.12 megawatt. And here power delivered by single circuit line is given as 43.56 into 2.65, and 2.65 is the multiplying factors. Here just now we have obtained 2.63 mF for 100 kilometer lines. So if you calculate for single circuit line surge impedance loading into mF, will get the power delivered by single circuit lines, and this is less than 140 megawatt. Again, power delivered by double circuit lines, and here the power for surge impedance loading is given as 87.12 megawatt for double circuit lines, and again if you multiply this with multiplying factor means 2.65, will get the power delivered by double circuit lines, and this is going to give 228.69 megawatt, and this is less than 140 megawatt. So conclusion can be made that since power delivered by a single circuit line is less than the required power to be delivered, so we select the double circuit lines with 132 kilovolt. It means double circuit line is selected with 132 kilovolt lines. So in this way we can calculate the numericals. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.